Hello there and welcome back. So this video is going to be about a way that you can technically benchmark how much time a function needs to produce a given value. And let's call this ClockWork.py. And what I had in mind is that we have the recursive Fibonacci implementation. So Fibonacci, and we give this the n argument, and if n is less than or equal to 1, then we return n, and otherwise we return the Fibonacci n minus 1 plus Fibonacci n minus 2. This will be the recursive Fibonacci, and we will have the factorial n, and technically what we have here is the if n is equal to 1, then we return n. Otherwise, we return the factorial n minus 1 times n. And if we take this for a test drive, so Fibonacci 10 or print factorial 10, this should be the result that we see. So Python 3, ClockWork. This seems to be about right. I'm not sure about this, but this is good. So now what we want to do is to create a decorator. How does this decorator look like? So in order to do this, we have to import the time module and the functools module. And basically, we are going to have the ClockWork as decorator, which takes a function. And we have the functools that wraps, and this is going to wrap the function. And we are going to have the clocked function inside, and it will take args and quarks. And basically, we should have a start, which would be time.perf counters. And the result is going to be func args and quarks. And we have the end, which is going to come from the time.perf counter minus start. And the name is going to be the function's name. And we are going to have the arg list, which will be a list comprehension with the wrapper arg for arg in args. And we have the arg list extended, which would be equal to extend, the following. So key equals value. Let's write it out. Key equals value. And we are going to use the for key and value in quarks.items. Can you see it? You kind of can. And the next thing that we want to do is to have the arg string, which is equal to join arg list. And what we will have is to print an f string. And this will take the end with 0.8f s and the name with arg string, and this is going to point to the result exclamation mark R, and we return the result and we return the clogged. Okay, now we would like to take these for a test drive. So ClockWork, and if you save it and execute it, arglist dot extend. Cool. So what do we see here? As you can see, we have the Fibonacci number, or actually the recursive call of the Fibonacci function with the result value, and the amount of time needed to compute it. And this is for each Fibonacci call. Good. And I think we have the LRU cache. And this should be able to help us speed up a little bit. So let's do this with the LRU cache. Functools, LRU cache, and just save it. And now if we run it, you can see that we do not have these duplicate calls, because if you want to represent this Fibonacci call, you would have a tree with branches and with duplicate function calls with the same argument. And the LRU cache is going to cache the response. And now only the distinct calls are going to be recorded. And we can also check this functionality with the factorial as well. So ClockWork. And if we run it, you can see that the factorial doesn't have an actual duplicate calls as well, but this is how the output of the function call looks like. And with this, we can see how much time each function call takes. And that was the idea behind this video. See you in the next one.